This next question is a slightly more typical genetic cross that you'll get with not just a Punnett square. So let's see what information we're given. A tall pea plant with terminal flowers. So we've got plant height and position of the flowers. Here they're at the end of the stem. Is crossed with a short plant that has axial flowers. All the offspring are tall with axial flowers. So all the offspring are tall with axial flowers. So what you see is you got contrasting characteristics for height, tall and short, okay? We don't know which one's dominant just yet. And we've got contrasting characteristics for flower position, terminal or axial. But you have these parents with opposite traits. So a tall parent with a short, terminal flowers with axial flowers, mating with each other. But all the offspring are tall with axial flowers. So that helps us assume that tall is going to be dominant and axial flowers is going to be dominant, because when you cross these two parents, you end up with the offspring showing the dominant trait. That's Mendel's law of dominance. So what I'm going to do here is I'm going to say T is for tall, big T, small t is for short. Axial flowers is dominant, so I'm going to do a capital A for axial flowers and a small a for terminal flowers. Now, let's have a look at the question. Name the dominant and recessive alleles. Very important, name the dominant and recessive alleles. So I'm going to say tall plant, that I've got to name it properly, axial flowers. Okay, I'm just using the information they've given to us in the question. Give the genotypes of the parents and the offspring in this question. So what I'm actually going to ask you to do, every time they ask you for genotypes in the next couple of questions, I want you to do a genetic cross. So let's set up our genetic cross in the same way that we always do. We just leave a little bit more space for the Punnett square. So the question gets quite tough here, where you see I've taken the phenotype straight from the question. Tall plant with terminal flowers crossed with a short plant with axial flowers. Always put your multiplication sign there. Now, we need to determine the genotype, but we know that all the offspring are tall with axial flowers. So that means this tall plant is going to have a big T, but it's going to have, because it's got terminal flowers, which is this recessive characteristic, it's going to have two small a's. This other plant is a short plant, so it's going to have two small t's, and it has axial flowers, so it's going to have at least one a. Now, if we look at the clue here, all the offspring are tall with axial flowers. So all of the offspring are going to have a big T, and they're all going to have a big A. Now, this parent can only give a small a to its offspring, so that means they will all get a small a from that parent. But at the same time, this parent can only give a small t, so that means our offspring are going to be heterozygous for both traits. But to determine the genotypes of the parents, whether this parent has a big T or a small t, that helps us here, that all the offspring are tall with axial flowers. Because if this parent had, let's just say, I'm going to put it in orange here, a small t here. They do not, okay? That means that that small t would possibly fuse with a small t from this parent, which means you could end up with some offspring that have two small t's, which would make them short, which is not the case, and we know this. So that means that both of the parents are homozygous for their complete traits, whether they're homozygous dominant or recessive. So I'm going to rub out the small t here, because that is incorrect. That means that this parent has a big T, two big T's, and that means that parent on the other side has two big A's, because it can only give a big A to its offspring. This parent can only give a small a. So all of the offspring end up being heterozygous. Whereas this parent can give a big T only, and this parent can only give a small t in terms of plant height, so all of the offspring are going to be heterozygous for height. So that's a little bit of a trickier question. So let's now copy that over. We're going to have tall plant with terminal flowers crossing with a short plant with axial flowers. The gamete combinations, this big T can join with a small a or that small a, but all of the gametes are going to be a big T with a small a for this parent, big T with a small a. Again, showing mating. These gametes are all going to be a small t with a big A. And then we just transfer those gametes into the Punnett square. Big T with a small a all on the top, small t with a big A all on the side. And if all of the offspring are getting a big T from the one parent, small t from the other, big A from the one, small t from the other, all of the offspring are going to be completely heterozygous for both traits. So what you can see I do here, and this is what I was training you for with a monohybrid cross, you can write the F1 genotype just on the side, because in some examples you're going to have many different genotypes here, so you don't want to copy them down and rewrite them. So I just label everything inside this Punnett square is the F1 genotype. Phenotypically, they are all going to be tall with axial flowers. This last question may seem like, how on earth do you predict that? But what you would have seen in one of the previous questions, where you had the two individuals that were both heterozygous for both traits mating, you ended up with a very important ratio where you have 9 to 3 to 3 to 1. The 9 is showing you that they've got both dominant traits. So you would have 9 tall with axial flowers. The 1 is showing you that they have both recessive traits. So you will have 1 short with terminal flowers. The 3 and the 3 is showing you that they've got new combinations. So 3 of them will be short with axial, and 3 of them will be tall with terminal, and those are the new combinations. So this ratio is only when the parents are, for example, heterozygous for both traits. So tall and a short allele, axial flowers, and a terminal flowers allele for both parents. You end up with this ratio of 9 to 3 to 3 to 1 in the F2 generation. When we did Mendel's crosses with monohybrid crosses, and the parents were both heterozygous, so if they were both just TT, and we were just looking at this one trait, the height, the offspring ratio is 3 to 1. Now, because there's 16 offspring, we have this very well-known ratio of 9 to 3 to 3 to 1. So the offspring will be 9 that are tall with axial flowers with the dominant traits. There will be 1 that's got both the recessive traits, short with terminal flowers, 3 that has 1 dominant trait, so maybe tallness and terminal flowers, and 3 that have 1 dominant trait, axial flowers, but with shortness, the recessive trait. For the rest of the lesson, you guys are going to do questions 11 and 12. I've left certain ones out on purpose. So let's read this through to help you a little bit. About 70% of Americans get a bitter taste from a substance called phenylthiocarbamide, PTC, let's call it. It is tasteless to the rest. The taster allele is dominant to a non-taster. So I'm going to use a capital T to represent a taster and a small t to represent a non-taster. I've seen this question in past exam papers. Also, normal skin pigmentation, that's the second trait, is dominant to albino. So I'm going to use a capital N for normal and a small n for albino. A normally pigmented woman who is taste blind, so she's going to have an N definitely, and she's taste blind. So she's going to have 2 small t's. We don't know if she is homozygous normal or heterozygous, but she has an albino taster father. So that means he had 2 small n's and a big T and a small t. But the 2 small n's are what we're focusing on. If the father was albino, he has 2 small n's. Of course, if he's an albino, he's got the recessive alleles. So that means he can only give his daughter a small n. So that's going to be her genotype. So she marries an albino man. I'm going to do it in blue here. So that's going to be 2 small n's, who is a taster. So he's going to have a big T, but we're figuring out whether he has a small t, if he's going to be heterozygous dominant for tasting, homozygous dominant or heterozygous. But this man's mother is a non-taster. So she has 2 small t's. The mother must have 2 small t's. So that means one of those small t's she gave to her son. So this is the man, the albino man, and this is her genotype, the normally pigmented woman. And you are going to do a genetic cross to show the offspring of those children using the phenotypes that are given. Now again, in pigeons, checkered pattern is caused by a dominant allele. So C for checkered, obviously we're going to make it a big C, and a small c for non-checkered, or I'm going to call it plain. Red color is caused by a dominant allele, brown is recessive. So R is red, small r is brown. So show the expected offspring between a homozygous checkered red bird. So homozygous means same. So it's going to be big C, big R, and a plain brown one. So if it's plain, it's got the recessive trait. If it's brown, it's got the recessive trait. So it has to be homozygous recessive, small c, small r. And you are going to do a cross between these two individuals to show all the offspring, and then you're going to do a second cross. You're going to cross the F1 offspring to get the F2. You can leave out question B. We will do that on Thursday when I come back.